So for the main presentation tonight, the other presentation, show of hands, things that don't go together. Military intelligence, I think, was the traditional one, right? Single sideband and high fidelity. Don't get it. Well, turns out things have changed. Smitty, come on up here. He's going to dispel all the rumors of it and show us how to talk like Donald Duck in HD.
You got it. You'll be surprised. It's not so much Donald Duck. It's more Rick Dees. All right. First and foremost, I want to thank you. Go ahead and go to the leader slide. Amateur radio redefined. We live in a hobby that some folks say is dying. Boo-hoo, right? I heard something on the radio. In fact, a couple of us have talked about this. Pat Walsh on KFBK was talking about how ham radio is dying. And I don't believe that. I actually don't think that. I think it's evolving. We have a bunch of great new digital modes, FT8, JS8 call, DV, what is it? Yeah, free DV, for example. There are all these new modes, and they're getting hams interested in this hobby at a level that they've never been. Younger hams, like, things like All-Star, and so we really are in a time now in this hobby where this hobby is really branched out, and it's growing, and it's gaining momentum and becoming relevant, or continuing to gain relevance with that younger demographic. Let me ask a few questions before I go to my next slide. Is any, well, not any band. Let's stick with one band, because this could be complicated if I ask the question the wrong way. Is 40 meters channelized? Raise the hands. That's true, right? True or false? Anyone think it's true? Okay, anyone think it's false? You should be raising your hands, by the way. It's not channelized, right? Okay, the FCC only allows single sideband at 3K or less. True? Is that true? Okay, is that false? Okay, we're going to talk about that. Next slide. What is ESSB? Some people say expanded, some people say extended, but the official designation is extended single sideband. I like to call it HFHD. And basically, instead of the typical 2.4, 2.8 signal that you put out on single sideband, ESSB runs roughly 4 to 6 kilohertz of audio. And we'll talk a little bit about what radios, and perhaps many of you in this room have a radio capable of doing ESSB, believe it or not. Is it illegal? It's illegal, right? No, not at all. The US FCC Part 97 sets no hard limits on HF phone emissions. And that little dinging is my Bluetooth receiver, so sorry about that. So ESSB is completely legal, other administrations don't impose bandwidth limits, as we know, other than, I believe, 60 meters, 40, 80, they aren't channelized. You can operate at a frequency, a half frequency, a quarter frequency, 10 kcs off if you want. At the end of the day, it's about the frequency, not about the channel or the bandwidth allocation. And its designation is right there as well, and it is recognized by the FCC. Next slide, please. Let's talk about the big station, the B1G station. Okay, so this is an extreme example, first and foremost. On the top of this rack is my SDR transceiver, and your hardcore ESSBers, this is what a lot of them run, but this is not required to start, and we are going to show you what you would need to start and what can be done just with software and just kind of the minimum point of entry. But I get this question a lot. What does my rack look like? I use an RE27 studio microphone that goes into a symmetric 528E audio processor. That is the first item under the blue box. That blue box is an Apache Lab, a non-7000 DLE. That is a transceiver, an SDR transceiver. It talks to my computer via Ethernet, and the computer is the actual control surface for it in case. And I'm going to, by the way, throughout the presentation, I'm going to kind of at times dumb it down a bit, only because I know we have some technicians in here. We probably have some folks, maybe aspiring hams that are out on the internet, for example. And so I want to make this broad for kind of a larger audience than just extras or generals or us HF folks. So the microphone goes into the 528E. The 528E goes down to the next device, which is an Aphex 3020D. And that does some leveling, and then that goes into the finalizer, or what I call my finalizer, which is an Orban, an Optimod 6300. And that's pretty much designed for FM broadcast, but I have it set more for AM. And then it goes out from there. It goes into an AES EBU DAC, basically a USB DAC into my computer, and I bring the audio in that way. And then, of course, my poor 7610 sits at the bottom of the rack, and sadly, I'm embarrassed to admit this, I have not turned that on in probably a year and a half. I have been absolutely hooked. Next slide, please. The most common thing we hear on the air, and we hear it all the time, did you know you're splattering? We get that all the time. It's a very misconception that ESSB signals take up unnecessary bandwidth. Incredibly, this happens all the time to us. We'll get somebody coming to us yelling at us that we're splattering, and they'll come in with a signal right there that you see next. So the one on the left, make sure left and right. Yeah, the one on the left, that is an ESSB signal. You'll notice there's a distinction to it. There's something very unique about that signal other than it being wide. You'll notice the one on the right, that is a traditional 3K signal or 2.9 signal. But does everybody notice what's the problem with that signal? And you see it all the time on the bands, right? What do you see there? Splatter, IMD, right? You see noise. Next slide. The IMD story. All right, your signal contains simultaneous tones. And, you know, there's a lot here, but essentially, strong nearby signals mix. Obviously, basically, this is just overview of kind of like what IMD is. And you can see in this example right here, this is a 3K signal, but it's an ugly signal. It's got, we call it, what do we call it? Hairs, or what do we refer to it? Fuzz. It's fuzzy. Next slide, please. So is ESSB like AM? For anybody watching or any tech, that is an AM signal. And one of its biggest differentiators that you can see here, similar in bandwidth, yes. Traditional AM modulation, or ancient modulation as we like to call it in ESSB land, is 3K on either side of the center frequency. So you've got your center frequency with lower sideband, of course. You use the 3K, or as many K as you want, 3K below upper sideband, 3K above the center frequency. But with AM, as you can see, you are right dead center, 3K below, 3K to the right, or up and down. And then, of course, you've got your carrier right there in the middle. Is it similar in sound quality, ESSB? Yes, I would say that it is, with some differentiators. First of all, in AM, as we know, it's got a center carrier. Second, signal length, you could see it looks just like, an ESSB signal, really. And unfortunately, my words are cut off on this printout. But it's important to note that standard AM is typically 3 up and 3 down, so 6K total, but most AM operators actually operate even wider than that. So the average, what you see is closer to around 8K total bandwidth used with AM. Next slide. Well, if ESSB and AM are so much alike, why not just do AM? Okay, there's a couple reasons why not. First of all, we've all been there, either on a repeater or on single sideband. I call it the dreaded double. It happens all the time, especially in the world of single sideband, because it's really sometimes hard to tell when somebody lets go of the key, right? So the dreaded double, obviously you don't have that with single sideband, and you do not have that with ESSB. On AM, you typically have a lower power limit due to the duty cycle. You've got your carrier power, and then of course your AM modulation. It's a little bit more complex to set up, and overall you can't run the same power. It's less efficient, of course. We know that just from studying your manual between AM and single sideband. One of the reasons why we use single sideband is it's so doggone efficient, right? Standard ESSB stations and 3K stations can coexist together. That's a great one, because of course, if you're doing AM and somebody comes up in single sideband or lower sideband or whatever, it sounds crazy, right? You've all heard this. Any generals or extras out there who have tuned in an AM signal and not been in AM know exactly what I'm talking about. Since single sideband is so prevalent in our hobby, This operating ESSB, I like to say it's backwards compatible, right? So even if you come to the frequency, you're still going to hear us. You're going to hear us at whatever your radio is going to allow you to hear us, typically 3 to 3.5K, for example. But overall, it's not. It's easy for somebody to jump into the QSO and have a blended QSO of we call them the narrows and the chunky signals, right? And then of course you have the better fidelity. Next slide. So why do we focus on this thing? Why do you hear ESSBers talk about cheese so much? We do, right? Right, Jim? Jim's an ESSBer, and block of cheese. We talk about the block of cheese, and why is the block of cheese so important to us? It's actually really simple. Every amplifier is noisy to some effect. Who in here has an amp real quick? Raise your hand. There's only two. Yeah, come on. There's got to be more than two of you. Okay, so you probably know your amp isn't entirely clean, and when you try to run full legal, no matter how hard you try, you're going to get a little bit of that peach fuzz on the sides of your signal. What pure signal does is it injects basically the cancel. It measures your IMD. So this right here on screen is a sampler. That's from VK Amps. So how it works is I've got my output of my amplifier. It goes into that device. And then I take that device, that little SMA on it, that's attenuated by, I think this one happens to be about 50 dB down. So I take that, bring that into the sample port on the transceiver, on the SDR, and you set on there basically how often you want your sample to happen. And as you talk, it samples your IMD and sends the adverse of that out beyond your transmit filter. So what you end up with is what we call the block of cheese. And we'll look at some examples of that, in fact. Pure signal is what it's called on the non-Apache labs. On Flex, you may see smart signal. That's really the same thing. And on ICOMs, if you own an ICOM 7610 and you have the latest firmware, it is called dynamic pre-distortion. And essentially that's it. It's dynamic because it's measuring your IMD and it's adding that distortion, but adding it phase canceled so that it cancels out that IMD and makes the block of cheese. Next slide. Let's look at a sample of a full legal signal. This is not AI. On the left is a QSO that we were having the other night, in fact. And on the right, you've got the other guy. What do you notice right off? Anybody notice anything real quick right off? You all got to participate. This is audience participation. The one on the right is a 3K audio signal, believe it or not. But it's 10 kC wide. That's how we measured it. So it's 3K of audio and 7K of IMD. It is incredibly common that operators like that on the right will come over to our frequency and yell at us for how wide we're running. It happens all the time. And then we say, well, you're running 10K. And when you think about it, the signal on the right, even though it's 3K and it's using the preferred bandwidth for audio on the air, bottom line is they're taking way more than 3K. You can't park up next to them because all that noise is going to be in the band pass and you're going to have a really, bad QSO for that matter. Now, you'll notice on the left, that's block of cheese. You notice that there's no hair on the sides. You're seeing pure signal at its finest right there. And both of these, well, I assume the one on the right, I don't know who the person on the right was, but it looked like a full legal signal. And on the left, you've got a full legal as well, 1.5 kilowatts. And you can see visually how clean it actually is. Next slide. How do I get started? You saw my audio rack, and it has a lot of overpriced gear in it. And part of that is I'm an ex-broadcaster, and I do voiceover on the side, so I owned a lot of that equipment. And I have multiple profiles set up on that equipment so that I can operate my rig and so that I can do Moonlight as a voiceover artist. But can you get started on a budget? In fact, I'll point at Mr. W6JCZ. He owns that microphone right there, the Fiduce SL40. Great microphone. It's a clone of the SM7B, but it's a great ESSB microphone to get started. Next in the chain, you've got your DAC. So you'll connect your microphone to that, of course. Your preamp is built into your DAC, and that's essentially what's going to, first of all, bring up the gain on the microphone, because you do need gain on any of these microphones that you'll use. And then it brings that audio signal into your radio. And then on the right here, this is a really popular project radio and a great first start into the world of ESSB. Who here, by show of hands, has heard of the Hermes Light? I know you have. Okay, so a few of you have. Hermes Light 2 gives you the capability to run ESSB. It is a SDR transceiver. The only limitation with this device, and there are many ESSBers that do this, they'll run a Hermes Light 2 and like an RM Italy amplifier to get up to 100 watts or 300 watts or 200 watts. So that combination does work pretty well. But essentially you can see here for, around $400 or so, plus or minus, you can too get started with ESSB if you want to do so. Okay, boy, I went through that a little bit quicker than I thought. I did want to leave some time for questions, of course, and then let's go ahead and go to the next slide, if that's okay. There are resources available. In fact, myself and the group that we call ourselves the ESSB Audio Outlaws, because we always get told how we're breaking the rules and how we're bad radio operators. It happens a lot. But if you want to check out n6mud.com, we typically will do, not every night, but several times. We usually start it up at about 7 p.m. and we rag you on 40. And if you don't have HF, you can go to this address. You could check out the YouTube feed and you can listen to what ESSB sounds like, or you can listen to it right now. I did bring some samples. So we'll do one real quick here, and then I'll play some other clips. I want to give you kind of some different profiles, different radios. The one thing before I show you the samples, I do want to indicate who here owns an FTDX10. Raise your hand. Okay, beautiful. Who here owns a 101D or a 101MP or anything like that? Raise your hand. Kenwood 890, Kenwood 990. Okay, so there are a few of you. You may not know this, but your radios can go out to 4K on transmit. And I think I actually left that out. That was on one of my slides and I left it out. What does ESSB devices do and what does the software do? It allows you to open up your transmit filter and essentially feed more audio in than a typical off-the-shelf radio. So those devices that I mentioned, the FTDX10, the 101MP, the 101D, there are actually several others out there, will allow you to open that transmit filter up to 4, and it's astonishing how much fidelity you get from going to 3 to 4. You wouldn't think there'd be a ton, but there actually is. So running 4K and running 4K cleanly has its benefits as well, and there are several. That's usually where ESSB land starts at 4. Most ESSBers do about 5K or 6K. But the one thing that I will say about this group and about every ESSBer, there's a group kind of like us on the East Coast, and when the conditions are right, we'll talk to them, and we'll kind of share tips and whatnot. We do have to be good stewards or better stewards than the average 3K signal. So we're always kind of watching our waterfalls and looking for stations that might be coming up in our bandpass, stations that we might be butting up against, because even with the pure signal, people still, they'll see that slice and they may not be able to hear us well enough, so they won't see that it's going all the way out to 6, or they'll think that's hash, or they'll think that's IMD, and they'll kind of butt right up against, and before you know it, we're together because we're all listening at 6, we're wide open to 6, and now we hear them in our pass band. So being an ASSBer does mean you have to be a little bit more cognizant about people that are around you on the band, and of course, continue to be respectful and be a good radio operator. All right, I'll play some samples here real quick, and then I do want to open it up for questions because there are a lot of questions about this mode, and there are a lot of different feelings about ESSBers, and I'd love to, hear those, and I'd love to maybe tamp them down. So let's go ahead and start with a clip. This first clip is obviously for you. This is a real clip. It was captured in San Diego. So from my base station to the receive point was San Diego. And it'll be pretty self-explanatory. And then I'm going to show you, it might go automatically into them, and if it does, I might as well kind of precursor and let you know. I have 3 different samples here of different operators, so you can hear different operators, the different sound profiles, and then I'll try to go one by one on its own because I want to show you a station that is similar in nature to that starting point, and then me, of course, with my crazy rack of gear, and then another station with a 950 SDX that's been modified, what's called the Voodoo modified. They're rare as hen's teeth, in fact, but they're really cool radios, and they also allow you, because they've been modified, to open up the TX filter and operate ESSB. All right, let's go ahead and hear the clip. Here we go. Nope. Hold on one second. I forgot to turn it up. Let's do that again. Here we go. All right, 3, 2, 1. There we go.
This is Smitty WB1G, and I'm going to show you what ESSB is all about. Right now, what you are hearing is 3 kilohertz with pure signal, the block of cheese that I talked about in the presentation, all right? Now I'm going to go ahead and bring that all the way out to full fidelity. Now you're hearing 6 kilohertz audio. So even though your radio at home may not hear the full 6, for folks that are rag chewing like this is what we sound like. WB1G, ESSB, out.
There was no digital noise filter on that. That was completely no DNR. It was a 20 over signal, so I was strong into that receive point, but there was no filtering. That was just raw analog audio at 6K. The next sample I want to play for you ever so briefly is a gentleman. He has a really nice mic, so his microphone is different than that SL40 that I showed earlier, the Fiduce mic. Matter of fact, Jim uses the SL40, and wouldn't you say it's a very good microphone for what is it, like $50, I think, with shipping?
Show the guys at work today the SM7B for
The people online can't hear you. You were showing here. Come over here.
So I was talking about Smitty's presentation over at work today, and the guys were talking about the microphone. I showed them the Shure SM7B on Amazon. I think it retails for $480, and I told them, what if you could take that decimal point and just scoot it to the left, 1 digit, and that's the SL40.
And the bottom line is whether it's an SL40 Fiduce for $50 or whether it's a RE27ND for $700, every mic needs an EQ, every mic needs a preamp, so ultimately you're treating the mics the same. You just may have to obviously EQ differently because very rarely are microphones truly flat. Here's another sample. This is a gentleman that's doing all of his processing in software. So he does not have a full rack of gear. He has an M audio DAC like what I showed on screen. And he's using Thetis, which is, who here's familiar with some of the software names out there? Thetis, Ether SDR. There's Zeus now. That's a brand new one. Yep, I see lots of hands going up. Or even your Flex radio software, for example. So this gentleman is doing all of his processing in the radio or in software. We'll give you this sample here.
Yeah, or I should say those fires that are up there have been really unstable. They've been shifting a lot with the wind.
Okay, so that profile right there, the example of what I showed you. Oh, I didn't do it. Did the people in Zoom didn't hear it? Okay, sorry, Zoom people. I'll let you hear the next one, okay? That gentleman right there, he's operating all in software. He is using a microphone different than the SL40, but believe it or not, that's what he started on, and he sounded pretty much like that on his SL40 as well. So that $400 investment level, yes, you can actually sound like that. Those software packages, Ether has a beautiful audio pipeline in it, by the way. Thetis has a great audio pipeline as well. So, and then I know Jim, for example, he uses Stereo Tools, which is software-based audio processing. There's Breakaway. There's a half dozen different solutions that you can use to kind of fill out that 6K to your liking. Another example here. Here's me again.
Similar issues, and I do have a cable going. Yeah, you're right. I just said RF Sense, and RF Sense is just for band switching. No, I do have the relay cable connected, by the way.
Okay, that was me, obviously. And again, 6K, just a different, I think that was a 20 over receive signal. And this last signal, and this happened to be recorded when this person was 35 over. Yes, 35 over. And he is running a Kenwood SDX modded, a Voodoo modified rig. It's a beautiful rig. They're super rare. And unfortunately, this particular rig, the Kenwood Voodoo rig, requires outboard gear. So you need a Smitty rack to do this. But this is my buddy down in SoCal.
Yeah, I know. My schedule just precludes me from doing that. And starting Sunday, I'll be incognito.
That last one that you heard is an SDX, an old Kenwood radio that's been modified to do ESSB. So there are a lot of options out there. It's a super fun mode, and it's very, if you're having a QSO, first and foremost, I should say, last thing to say here, it's not, I don't contest like that. It makes absolutely no sense. I don't contest at all. I don't contest with that kind of audio profile. However, it is very easy to set up different profiles, and I press the button, and then I'm down to 2.9 to 100, and I'm cut right. My bass, you could hear there's a lot of low-end modulation. Obviously, part of that is the speaker itself, the 15-inch speaker here, but it's also, that is the characteristic, because we're not rolling off at 100 hertz. We're going all the way down to, technically not zero. Most of us kind of roll off at about 20 hertz, but as you can hear, from 100 to 20 hertz, that's really where the boom booms, as Jim puts it, the boom booms come in. Yeah, you had a question?
Yeah, how much does this affect your power? So if you are, modulating instead of 2.8, you're modulating 6 with an average.
Great question. The question was, how much does this affect your power? And I'm going to answer it a couple different ways, if that's okay, Brian. First and foremost, it doesn't. However, it does affect the concentration of your power, right? Because you're taking that power and you're spreading it across more bandwidth. However, when you narrow it down, because of the processing, because of this, I find that my overall peaks, this is the other way I'm going to answer this, Brian. A 3K signal with an ICOM and the compressor on, you'll look at that ALC meter and you'll see it doing this, right? It looks like a VU meter. And so your power may be 8 watts and then go to 100, we're pretending you're barefoot, back down to 10. And so you're constantly seeing your ESSB, since there's no center carrier, it's not AM, it's moving, right? As you speak, your voice is driving the radio, the amplifier, or driving the radio that drives the amplifier. With ESSB, how we are configured, our ALC in general looks more like this, like a broadcaster. So we're maintaining, in the world of single sideband, we're maintaining a higher overall total power output of our radios and our amplifiers, which, as you can hear, does create a more boomy, louder sound. Now, if you tune that in on a 3K radio, it actually sounds quite good. I know there's several of you that have heard it. It might be a little low-end heavy, so that's why a lot of ESSBers will modify their profiles and change the roll-off at the low end, because going down to 20 hertz and hearing that on a ICOM or a Yaesu, just a regular speaker in a radio, we tend to vibrate the woofers quite a bit there. So, how much compression am I using? That's a hard question to answer, because I'm using 3 stages of compression. In my world, I'm using a compressor and a gate at the mic processor. I've got a parametric EQ there, so that first item in the rack. The next item in the rack does some very transparent leveling. I only have it there because it's doing a D to A conversion for me, so it's really, I have it set up pretty flat. And really the OR band is what's doing most of my major compression, so it's taking the output of that compressed microphone level, and it's finalizing it. It's really adding, they call it the OR band sparkle, or the Optimod sparkle. You don't need an Optimod. I have one. I have several of them for radio and my time in broadcasting. So to answer how much compression, it isn't one number, like where you have compression on a ICOM or a Yaesu. You can't turn it from 2 to 10 or anything like that. You're really adjusting, in my case, 5 different bands, and then you're also adjusting in those 5 bands how wide each band is, your Q, or how wide your EQ adjustment is. So you have a full parametric of these bands, and you have ultimate control. So, Rich, to answer your question directly, it's not really a number. You can turn up more or down, you can adjust those thresholds, but it isn't quite as easy as just a number, unfortunately. 2 more questions. See, I said I finished quick, but I knew there were going to be questions. Greg, do any of the web SDRs support it? The answer is yes, they all do. Kiwi and WebSDR support this. So if you wanted to come out and listen, you don't necessarily have to go to YouTube. You can go to any of the WebSDRs that are out there. It's a little tricky. When you get out there, it'll default to 3K. But if you go to where the waterfall is on the WebSDRs, you'll see there's kind of 2 little things like this, like almost look like 10 poles. Take that 10 pole right there and slide it out, and you'll be able to widen out the receive filter on that. You'll be able to hear it yourself. Yes?
Bandwidth available with a $400 starter pack.
The bandwidth available, same bandwidth that we're using. Matter of fact, you'll be using the same software that I use at home. So you'll be able to do, truly, my radio will do up to 15K. I've never taken it to 15K. I have taken it to 7, but it will do up to 15. Brian, last question.
comparison between hardware and software. A lot of us have the free Ether SDR. How would that free stack compare to your hardware?
Sure. That's a good question there, Brian. Brian asked, the full stack or the full rack of audio gear versus software, like the Ether SDR audio pipeline. I got to tell you, and I'm doing this for Kilo Golf 9 Mike, I'll be frank with you. To my ear, they are darn close. You heard that file I played a little bit earlier with my buddy Jeff. That was all software, and he sounded a lot like me, really. I mean, I think with the full rack, what you get, Brian, is you get a lot more of the ability to adjust the density overall, and which also affects your power density, your TPO coming out, because the more you can keep it, without distorting, of course, but the more you can keep it, close to the line, the more density of that total power output you can do. All right. Thank you so much. If you want to talk about this at any point, you could check the website out, of course. That QR code works. And I love talking about ESSB and audio, so don't be shy. I'm happy to discuss it after if you want to. Thank you very much.